Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let's look at some examples using polynomial functions. Let us say we want to evaluate this indefinite integral x squared plus 1 x squared plus x minus 1 dx. This is a polynomial function in x. So when we have a polynomial function of this kind, we can integrate each one of these functions separately as shown here. Integral x squared dx plus integral x dx minus integral 1 dx. Since we know the rules of integration, we're going to apply those integration rules to simplify this particular problem. For the first part, we can use the power rule. For the second part, also we can use the power rule. And for the third part, we can use the constant rule of integration. When we use the power rule for the first part, integral x squared dx, it simplifies to x to the power of 2 plus 1 divided by 2 plus 1 plus integral x dx. Integral x dx, here too we can use the power rule. Integral x means x to the power of 1. When we use the integration process, we can write it out as x to the power of 1 plus 1, the whole thing divided by 1 plus 1, minus integral 1 dx. 1 if we take it outside of the integration process, integral dx converts to x. So 1x or x means the same thing, plus c is the constant of integration. Whenever we complete the integration process, we add the c to the end of the solution as shown here. So when we simplify this process here, x to the power of 2 plus 1, x to the power of 2 plus 1 converts to x to the power of 3, and the denominator we have 2 plus 1, which is 3. And then next we have x to the power of 1 plus 1, which converts to x to the power of 2, and in the denominator we have a 2 minus x plus c. Now when we simplify this some more, this is our solution. We can also write the solution as shown here. 1 over 3 x cubed plus 1 over 2 x squared minus x plus c. This and this is exactly the same. So you can either represent your solution in this format or in this format. It is exactly the same. We want to make sure that we always add the c to the end of the solution when we complete the integration process. Let's look at another example. Let's say we have a polynomial in t this time. Integral, we want to evaluate this indefinite integral 2t squared plus 5t minus 3 dt. Since this is a polynomial in t, and since we have three functions inside this example problem, we can separate it out and write it out as shown here. Integral 2t squared dt plus integral 5t dt minus integral 3 dt as shown here. Okay. Now we're going to use the process of integration to each one of these functions and then simplify them. For the first part of the problem here, we can use the power rule. For the second part too, we can use the power rule, and for the third part, we can use the constant rule. So when we use the power rule for the first part, since 2 is a constant, we're going to take it outside of the integration process, and when we integrate integral t squared dt, it converts to t to the power of 2 plus 1, the whole thing divided by 2 plus 1, plus in the second part, integral 5t dt, 5 is a constant. We're going to take that outside of the integration process as shown here. Integral t dt converts to t to the power of 1 plus 1, the whole thing divided by 1 plus 1, minus integral 3 dt in this part. 3 is a constant. We're going to take that outside of the integration process. Integral dt converts to t. So 3 times t is 3t plus c is a constant of integration. So when we simplify this process, it converts to 2 times t to the power of 2 plus 1 is t cubed as shown here, and then in the denominator we have 2 plus 1 which is 3 plus 5 times t to the power of 1 plus 1 is t to the power of 2, and in the denominator we have 1 plus 1 which is equal to 2 minus 3 times t plus c. This is our solution. We can write this solution. We can also represent our solution as shown in the next step here. 2 over 3 t cubed plus 5 over 2 t squared minus 3t plus c, where c is the constant of integration. As we mentioned before, whenever we arrive at the solution for an integration process, we're going to add a constant c at the end of the solution. In my next video presentation, we will be solving problems using the rules of integration.